So good day everyone, we are now going to discuss our topic, which is the geodetic datum and datum transformation. So in surveying and geodesy, a datum is a reference system of the Earth's surface against which positional measurements are made for computing locations. Geodesists and surveyors use datum to create starting or reference points for floodplain, property boundaries, construction surveys, or other work requiring accurate coordinates that are consistent with one another. So a datum is a mathematical model that approximates the shape of the Earth to enable accurate position, the length, and the area calculations. Example of a datum is the WGS84, which is generalized model for the whole planet. So the WGS, or the World Geodetic System, was established in 1984. So there are many datum in use. So almost every country has its own datum because there are specific places where cartographers are not satisfied with the WGS84 datum because there are area falls outside the datum model that affects the length, the area, and the position calculations, so they would prefer another datum. So a datum can be either a global datum, so example is the WGS84, and also local datum, example is the NAD83. So when we collect GPS data, it is advisable to have datum on the GPS set, the same as the GIS system that we'll use to display or store the data. So if the data will be imported into Google Earth, then the datum should be WGS84 because generally this is also the default datum for smartphones. So due to advances in measurements moving, example is the plate tectonics, the WGS84 will one day be replaced. Reference system is a complete conceptual definition of how a coordinate system is formed. It defines the origin and orientation of fundamental planes of axis of the system. It also includes the underlying fundamental mathematical and physical models. So it is also unattached to the real world. So in short, the reference system is the whole concept of the system. So since a reference system is a concept, its basis is the fundamental mathematical and physical models. A reference system still remains unattached to the real world. So it is the office of the realization. So the establishment of real positions on the surface of the earth for it to become a reference frame. A reference frame is the practical realization of a reference system through observations. It realizes the reference system by means of coordinates of definite points that are accessible directly by occupation or observation. It consists of a set of identifiable fiducial points on the sky or on the Earth's surface. So in practical surveying, it only concerned with the reference frames, but underlying concepts of a specific reference frame are of fundamental importance. So reference frame is the realization of the reference system. It is made possible through physical points on the Earth's surface, satellites in near Earth orbit, and celestial objects, along with parameters describing geometry and gravity over time. The reference system and the reference frame depend on one another. Neither is useful without the other, just as positions on the Earth are useless without an origin, orientation of the axis or definition units, and so on. So without a reference frame, the coordinates of control points are like chess pieces. Without a chessboard, they can be arranged, they can be analyzed and moved about, but they have no meaning.
Luzon 1911 datum. The province of Marinduque, dubbed as the heart of the Philippines, is a heart-shaped island in southern Tagalog region. It is such a coincidence that the heart of the Philippines has a landform shaped like a heart, and also, coincidentally, the island is also the geographical center of the archipelago, and a stone marks its significance in Philippine geography. The Luzon Datum of 1911 or Station Balanacan is the known stone marker which is located on top of a hill that locals call Mataas na Bundok or Mount Mataas in Barangay Hinangayon. If we want to locate or to go to the Luzon Datum, we can simply ask it in the locals in Marinduque, for it serves as a tourist spot nowadays. The Luzon Datum is the primary geodetic reference or origin of all geological surveys in the Philippines, which means all maps and surveys in the country use this as a reference point. In engineering and drafting, a datum is a reference point surface or axis on an object against which measurements are made. These are then referred to by one or more datum references, which indicate measurements that should be made with respect to the corresponding datum feature. The National and Resource Information Authority or NAMRIA is the central mapping agency of the Philippines that recognized the Station Balanacan as the official datum, because there were arguments that the datum should be at Romblon Island and not in Marinduque. The Station Balanacan is located in Marinduque and it is approved by the NAMRIA to be the official datum. According to NAMRIA, the triangulation station Balanacan was established by the U.S. Coast and Geodetic Survey in 1906 as part of a nationwide triangulation network and designated as the origin of Luzon Datum 1911. Up to the 1990s, the Luzon Datum serves as the primary reference frame for all survey and mapping activities in the country. The Philippine Reference System or the PRS-92, the present Geodetic Reference System, is a modified and updated Luzon Datum and still uses the Station Balanacan as datum origin. The historical significance and importance of the Luzon Datum origin is recognized in the surveying and mapping community. Up to the 1990s, the Luzon Datum served as the primary reference frame for all survey and mapping activities in the country. Next is the Philippine Reference System or the PRS-92. The Philippine Reference System is the present Geodetic Reference System. It is modified and updated Luzon Datum and still uses the Station Balanacan as datum origin. The PRS-92 is the new name of the Luzon Datum because it still uses the Station Banacan as the reference point. PRS-92 is a local geodetic datum established using the Global Positioning System or the GPS under the Geodetic Survey component of the Natural Resources Management and Development Project NRMDP, an undertaking in partnership with the Government of Australia. It was designed to be the reference framework for all surveying mapping that will replace the primary triangulation network of the country established by the U.S. Coast and Geodetic Survey from 1901 to 1927, whose accuracy was found by NRMDP to be less than third order based on the current standards. The PRS-92 comprised of 471 first to third order stations, 84 of which were common to the triangulation network. It retained most of the parameters of the old Luzon Datum of 1911. The adoption of PRS-92 as the standard reference system for surveying and mapping activities was mandated through Executive Order No. 45, Series of 1991. This law was subsequently amended, the latest being Executive Order No. 321 Series of 2004, extending the deadline for the full adoption of the new system until 2010. However, Problems with integrating existing land survey datasets into PRS-92 have resulted to users still referring to the old Luzon datum for their surveying and mapping. Regional Environment and Natural Resources offices, which are mandated to undertake the data integration, have experienced difficulties in integrating the old cadastral datasets due to the inconsistencies and errors in the old survey. The Philippines is located in a tectonically active region that is subject to an average crustal drift of 2 cm per year, not to mention the local distortions brought about by earthquakes. PRS-92 being a local and static datum fails to account for this distortion.
What is geodetic datum? So geodetic datum or geodetic system is coordinate system and a series of reference points used to locate the places on the earth or similar objects. It combines latitude, longitude, height, and time information. So let's define first latitude. So latitude is the geographic coordinate that specifies the north-south position on the point on the Earth's surface. Then longitude is the geographic coordinates that specify east-west position on the Earth's surface. Next is height. Height is sometimes described the elevation of the Earth's surface. So when we hear the word height, it refers to the elevation of the Earth's surface. Next is the height information. So height information derived from GPS is relative to something called an ellipsoidal model of the Earth instead of the sea level. So what is an ellipsoidal model of the Earth's surface? So, ellipsoidal model of the Earth meaning the Earth is not a perfect sphere, but it is instead more likely slightly squashed sphere called an ellipsoid. So an ellipsoid looks like a ball, then someone is sitting on it. Instead of being perfectly round, it is squashed from top to bottom and bulged out from the side to side. So imagine a ball. So the shape of the ball is circle, and with someone sitting on it, and that is an ellipsoid. So the ellipsoidal model of the Earth looks like a ball and someone sitting above it. So these are the commonly used geodetic datum or reference system. So first, the North American Datum of 1983 or NED 983. So, is the nation's horizontal or geodetic datum. It provides latitude and longitude and some height information. The North American Datum of 1983 is the horizontal and geometric control datum for the United States, Canada, Mexico, and Central America. NED 83 was released in 1986. State-by-state adjustments were completed in 1900s, an effort referred to as High Accuracy Reference Network. So, NED 83 or the North American Datum was recognized as the Accurate Reference Network. So, the next is the North American Vertical Datum of 1988 or NAVD 88. So, it's the nation's vertical datum providing elevation information relative to the reference surveys defined by mean sea level. So, the North American vertical datum is not just used to give locations of the places on the earth. It also gives you elevation and relative to the reference surface defined by the mean sea level. So, next is, but what is the mean sea level? So, it's an average surface level of one or more and the Earth's coastal bodies of water from its heights such as elevation may be measured. So, when we say mean sea level, it is the average measurement of the sea level along the coastal area through the Earth's surface. So, North American Vertical Datum of 1988 consists of leveling network on the Earth. So, in the North American continent, ranging from Alaska through Canada across the United States, affixed to a single origin point of continent. Then next is the North American Datum of 1927, so NED 27. So, it is defined by the latitude, longitude of an initial point. So, this initial point is the Meades Ranch Triangulation Station in Kansas. So the direction of the line between this point and specified secant point. So, and two dimensions that define the spheroid. So this datum particularly locate by the use of triangulation. So it also defines the latitude and longitude. So when we say triangulation, it is the measurement of a series or network of triangles. So in order to determine the distances and the relative position of points. So the series of measurement is used to define the triangulation of an area.
The responsible organization for the World Geodetic System 1984 is the National Geospatial Intelligence Agency. So what is this National Geospatial Intelligence Agency? So the GEOINT stands for Geospatial Intelligence, which is a discipline that comprises the exploitation and analysis of imagery and geospatial information to describe, assess, and visually depict the physical features and geographically reference activities on Earth. So its abbreviated frame name and its associated terrestrial reference system are the same, which is WGS-84. It is global and it is three-dimensional. Before this version, they had the WGS-84 G167 and its reference epoch is 2005.0. So according to my research, WGS-84 is Earth-centered or Earth-fixed, which means that it represents the Earth as a center. The WGS-84 expresses the properties of the Earth that is based on a consistent set of constants and modal parameters. It is also the standard U.S. Department of Defense definition of a global reference system for geospatial information. It is also used as the reference system of the GPS and is compatible with the ITRS. Now, let me discuss about the definition of frame of the WGS-84. So, the origin is Earth's center of mass being defined for the whole Earth, including oceans and atmosphere. So there are three axes. The z-axis, first in line, it is the direction of the IERS reference pole or IRP. This direction corresponds to the direction of the BIH conventional terrestrial pole or the CTP. Its epoch is on 1984.0 with an uncertainty of 0.005 seconds. So next is the x-axis. So the x-axis is the intersection of the IERS reference meridian or IRM and the plane passing through the origin and the normal to the z-axis. The IRM is coincident with the BIH 0 meridian and its epoch is on 1984.0 with an uncertainty of 0.005 seconds. The y-axis completes a right-handed Earth-centered, Earth-fixed, or ECEF, orthogonal coordinate system. Its scale is that of the local Earth frame in the meaning of a relativistic theory of gravitation aligns with ITRS. The orientation is given by the Bureau International des Ors, or BIH orientation of 1984.0. Its time revolution in orientation will create no residual global rotation with regards to the crust. So the Cartesian coordinates x, y, z, WGS-84 or G1674 follows the criteria outlined in the International Earth Rotation Service or IERS Technical Note 21. The WGS-84 coordinate system origin also serves as the geometric center of the WGS-84 ellipsoid, and this z-axis serves as the rotational axis of this ellipsoid of revolution. WGS84 geodetic coordinates are generated by using its reference ellipsoid, so its defining parameters. So there are 4 identified parameters of the WGS84. These are the semi-major axis of the WGS84 ellipsoid, the flattening factor of the Earth, the nominal mean angular velocity of the Earth, and the geocentric gravitational constant as specified below. So the references are the NEMA Technical Report 8350.2, Department of Defense, World Geodetic System 1984, its definition and relationships with local geodetic systems, Addendum to NEMA TR 8350.2, Implementation of the World Geodetic System 1984, WGS84 Reference Frame G1150, so the Navstar Global Positioning System Interface Specification IS GPS 200 and Navstar GPS Space Segment or the Navigation User Interface. The WGS84, G1674, and ITRF 2008 are completely aligned with a similar epoch, which is 2005.0. The alignment is used to establish scientific integrity and follow best practice. The ITRS uses methods, and if the WGS84 will be adjusted with this, it will be a convenience for the reference frame. So the WGS84 G1674 adopted the values of NGA stations coordinates in the ITRF 2008 reference frame, with the exception of its stations located in Bahrain and Korea. Computations were performed to align the remaining WGS84 reference stations to this network. For WGS84 G1674, all WGS84 reference stations adopted ITRF 2008 velocities of the station or nearby sites. The estimated accuracy of WGS84 G1674 is better than 1 cm overall for each of the reference frame station coordinates. The 7-parameter transformation from WGS84 G1674 to ITRF 2008 is 0 in all components. This is by design since WGS84 G1674 adopted ITRF 2008 coordinates and velocities in common stations between the 2 reference frames in all but 2 exceptions. This process ensures that WGS84 is aligned to ITRF 2008 to better than 1 cm at initial WGS84 G1674 release. So here is the table for the transformation of parameters. The parameters are defined from the listed reference frame to WGS84 or G1674 at epoch 2005.0. So on the first column are the reference frame, and below that is the reference frame epoch. So WGS84 G1150 and its reference frame epoch is 2001.0. The ITRF 2008 and its reference frame epoch at 2005.0. On the second column is the TX, MM, Sigma. So WGS84 G1150 have a TX, have a MM negative 4.7 and 5.9 sigma. And for the ITRF 2008 is 0. Next, the TY. So the Ty of the WGS84 G1150 is 11.9 and 5.9. And again, ITRF 2008 is 0. The TZ of WGS84 G1150 is 15.6 and 5.9. Next in line, the D, the WGS84 G1150 has a PPB of 4.72 and 0.92, and again, ITRF 2008 is 0. So RX, next in line, the WGS84 G1150 have a negative 0.52 and 0.24, and then again ITRF is the same, 0. So the RY, the WGS84 G1150 have a negative 0.01 mass and 0.24 sigma. And then again, ITRF 2008 has 0. So the last one is the RZ, which WGS84 G1150 has a negative 0.19 and 0.22, and also the ITRF 2000 have 0. So the number sign is the sign convention for the rotations Rx, Ry, and Rz is what NGA uses in its orbit comparison programs and is opposite to that of IERS technical note number 36, equation 4.3 and following, 0 by constant. So here is a short discussion about the relationship of GPS and the WGS84. So the GPS reference system is WGS84. GPS users directly receive WGS84 coordinates from a GPS receiver if no changes to the reference frame are selected or made. The software that generates GPS broadcast orbits is updated at the beginning of each calendar year with an epoch at the half-year mark to account for plate tectonic motion. This method results in a yearly stepwise adjustment of WGS84 coordinates delivered through GPS broadcast orbits. For example, GPS broadcast orbits at the time of this writing have an epoch of 2012.5. Reference frame station locations are updated for any sudden displacement, such as an earthquake. The DoD precise GPS orbits generated by the NGA incorporate plate motion by using the WGS84 reference stations propagated forward using reference station velocities. The NGA plans to conduct a WGS84 reference frame network adjustment in early 2013 to incorporate IERS Conventions 2010 Technical Note 36 or TN36. Note that WGS84 will retain its 4 defining parameters, of which some do not comply with TN36. When completed, the newest realization of WGS84 will be published, and NGA, formerly NEMA Technical Report 8350.2, will be updated. So what's the difference between the PRS-92 and WGS84? So the PRS-92 is based on the World Geodetic System of 1984, which is the WGS84, which makes use of the GPS. Prior to the PRS-92, the country uses the old National Geodetic Network called the Philippines Geodetic Network, which was established by the United States Coast Guard and Geodetic Survey in 1901 to 1946.
Datum transformation method, depending on the to and from datum involves. Different transformation methods are used. In both the 3 and 7 parameter methods, the transformation align the x and y axis of the two datum in the three-dimensional Cartesian coordinate space. The 3 parameter methods in the three-parameter transformation, also called a geocentric translation. The axes of the two datums are aligned using the linear shift of the x, y, and z axis of the datum being transformed. The three-parameter transformation is the appropriate when the x and y and z axis of the two datums are parallel and identical scale. 7-parameter methods. A 7-parameter transformation is used when the axes of the two datums are not parallel and identical scale. In addition, the three linear shift parameters, there are three rotation parameters, one for each axis and scale factor. NADCON method or grid-based. Another type of transformation, called a grid-based transformation, is available for converting between the NAD27 and NAD88 datums. This type of transformation is more accurate than the equation-based method described above. It relies on the fact that the exact latitude-longitude difference between the two datums have been calculated for 1,000 of control points. Essentially, what happens in the transformation is that point coordinates on the from datum, usually NAD27, are moved to the correct location on the two datums simply by looking up the latitude and longitude differences from that location in a table. The exact amount of the shift has not been calculated in the advance for every point, of course, but every point does fall with a grid cells which has bounding control points of known shift. The amount of shift for a point with that cell can be estimated by interpolation. Molodensky method. The Molodensky method transforms the latitude-longitude coordinates of the from datum directly to the latitude-longitude coordinates of the two datum, thus escaping the process of converting both datums in the three-dimensional Cartesian coordinates. It uses linear shift of the x, y, and z axis of the from datum spheroids, plus the difference in the semi-major axis and the flattering ratio of the two spheroids.